Ladies and gentlemen, welcome to our Wednesday Lowy Lunch for this week. Lord Mayor of Oxford holds a professorship jointly at Oxford University and Imperial College London and is a Fellow of Merton College, Oxford. Between 2000 and 2005, he was President of the Royal Society and before that Chief Scientific Advisor to the British Government and Head of the British Office of Science and Technology. He is also, among other things, a member of the British Government's Climate Change Committee, a non-executive director of the British Defence Science and Technology Laboratories, and until recently chaired the trustees of the Natural History Museum. His career includes a personal chair in physics at Sydney University at the age of 33, a professorship and chair of the research board at Princeton University, and he was awarded a knighthood in 1996 and appointed a Companion of the Order of Australia in 1998, both for his services to science. In 2001, he was one of the first 15 life peers created by the House of Lords Appointments Commission, which was established as an independent mechanism for appointing non-party political peers following the removal of the voting rights of hereditary peers. In 2002, the Queen appointed him to the Order of Merit, and his many other honours include the Royal Swedish Academy's Crawford Prize, the Swiss-Italian Balzan Prize and the Japanese Blue Planet Prize. In 2007, he received the Royal Society's Copley Medal, which is the oldest medal given out by the Royal Society. He is a foreign member of the US National Academy of Sciences, an overseas fellow of the Australian Academy of Sciences, and an honorary fellow of the Royal Academy of Engineering. I'm also proud to say he is a member of the Lowy Institute's International Advisory Board. Lord May, welcome to the Lowy Institute again.
What I am going to do is, I'm not going to give a reprise of the Lowy lecture of 2.5 years ago, but I do begin from the point that, if you remember last year, there were an enormous number of public lectures celebrating Darwin's 150th. In the 150 years since Darwin gave us a sense of how we got to be where we are, human population has increased 7-fold, and the ecological footprint, particularly the energy use of the average inhabitant of the globe, with great variations in different places, has increased 7-fold, so that our impact on the planet has increased by a factor of roughly 50. No other species has ever done anything like that in so short a time. And it makes for enormous pressures on ecosystem services, which aren't counted as part of conventional GDP, but are of similar magnitude in crude estimates, on how we're going to feed half as many people again, on supplies of water, and on climate change. That's what I'm going to focus on today. And what I'm going to do is, in a very rough gallop across the landscape, I'm going to talk first about what we do know about climate change and some of the uncertainties that there still are. And against that background, in the second part, I'm going to talk about what the United Kingdom has done by way of legislation and targets and how they went about doing it. And in the third part, I'm going to widen the horizons to ask what next after the comparative failure of Copenhagen. And I'll try and do that quickly enough that there'll be plenty of time for questions. And I realise this is a subject about which there is a good deal of discussion, and in Australia at the moment, and I will reserve my opinions on that for the questions I might get. This is a look back over 60,000 years to essentially the thickness of one of the most important constituents of the greenhouse gas blanket which coats our planet and without which it would be a frozen ball, uninhabitable. And during the during the 4 billion years in which our planet has existed, and the 500 million years in which we have a fossil record of forms of complex life, there have been times when arguably the planet may have been something quite close to a snowball, and other times when exotic tropical animals roamed the poles. During most of our tenancy, a couple of 100,000 years, ice ages came and went in a way that's now reasonably well understood. The last 10,000 years, roughly coincident with the dawn of agriculture and the beginning of the first cities, the beginning of recorded history, the thickness of the greenhouse gas blanket has been relatively steady at about 280 parts per million, plus or minus 10 parts. There are those who say this odd stability is partly associated with the rise of agriculture, but that itself is controversial. And there is, however, no reason to have expected any particular change were it not for the fact that a couple of 100 years ago, as a result of the Enlightenment, really, and the dawn of the application of that understanding in technological expansion and the burning of fossil fuels, we have really begun to change things. Today, in a given year, we burn roughly 1 million years worth of fossil fuel deposits. 1 million years worth of plants that fixed, using the energy of the sun, fixed carbon, put it under the ground, we've taken it out again and put it back into the atmosphere. That is, we're absolutely certain of. What we're less absolutely certain of, and certainly were less absolutely certain of 30 years or so ago, is how you translate that thickening of the blanket, this complex interplay between sunlight coming down and heat being re-radiated back into space, how that translates into changes in the average temperature. On the other hand, over the last 25 years or so, each 18 months computational power has doubled, so that we have seen something like 10 doublings, a factor of 1,000 in the computational power. And I summarize that here by showing continent by continent. The light blue shows what an ensemble of different computational models run by different groups suggest would be the understanding of how the climate, the average temperature may have varied if you excluded our burning fossil fuels. The purplish things show the band of ensemble of models putting in the burning of fossil fuels, and the black line is what has actually happened to the temperature. It hasn't moved smoothly up. It's had wiggles in it. And our predictions about what is going to happen over the next 10, 50, 100 years have many uncertainties in them still as to the timescales, the speed at which certain complicated nonlinear processes may accelerate or, on some rare counterexamples, slow the rate of translating the thickening of the blanket into warming. Some of these things have to do with the release of methane, another greenhouse gas which is more powerful per unit weight, as it were, than CO2, but on the other hand only stays up there characteristically for a decade, whereas the average molecule of CO2 that we put up these days, on average, very complicated distribution of this, but the characteristic residence time is about 100 years. There are uncertainties as to the degree to which fresh water from glacial melt moving in to places like the Gulf Stream slows the current, as has clearly happened in the past, and there are those who suggest that sometime in the next 100 years it could even turn off the Gulf Stream, as it has done in the past, although most would put that much further into the future. And so there are a set of these things that give us uncertainties as to the detailed timescale of events, but no uncertainty as to the fact that we are making changes in the climate, moving us. It took us about a century and a half after 1780, when we first started burning fossil fuels, to move outside that 10 millennia envelope of 280 plus or minus 10 parts per million. But then over the last century, it took us, by about 1930, we were getting up to 315 parts. By the 1960s, we were up to 330. By the 1990s, we were up to 360. And in the last 10 years, we've taken it up more than 10, up into round 380, 386, 387. We're headed on an optimistic scenario, assuming we act effectively, we're headed to something like 2 degrees, maybe 4 degrees, 2 degrees by the middle of the century on an optimistic projection, and maybe 4 degrees by the end of the century. And the last time we saw that on Earth was several tens of millions of years ago. And when Earth at that time came to equilibrium with that, the oceans were about 100 meters higher. It's difficult to relate to this. It's difficult to relate to this. It doesn't fit with intuition because we all know, I mean, we've been told we should be worried there's 0.7 degrees temperature increase last century. I mean, that sounds ridiculous when the temperature changes 5 degrees centigrade from one day to the next. And why should that worry you? You'll be aware that we've just had a really cold winter in Britain with this purplish blocking phenomenon, which could conceivably be associated with features of the Gulf Stream change, but maybe not. It's happened before. And people quite sensibly say, how can you be sure of anything when you're telling us it's getting warmer and it's bloody cold this winter? And in fact, it still is, and it's supposed to be spring. Nonetheless, on average, the Northern Hemisphere was hot this year. It's just that with that blocking phenomenon, Britain has been having the kind of climate that it really ought to have if it weren't, if it were Sweden, as it were, and it weren't being helped by the Gulf Stream. To get another way of looking at that, we know how ice ages, by and large, were driven by small changes, predictable changes in the Earth's orbit round the sun and the tilt. And you can, on that basis, make a calculation that if we hadn't been burning fossil fuels for the last couple of 100 years, the Arctic would probably have cooled by about 0.2 degrees per millennium for the next 4,000 years. And that may be slowly bringing us, on the scale of tens of thousands of years, to another set of ice ages. So no one is saying that what we've enjoyed for all of recorded history is going to be there for all time. But I am saying that is a serious change, 0.2 per millennium. But that's, of course, not what we've seen because we've managed to overcome that by quite a bit. And yet it's hard to relate to that intuitively, and I think that's one of the many problems. In short, there is no doubt about the basic facts, and this is a statement unprecedented of its kind that was issued in 1995 by the Science Academies of the G8, the United States, Japan, Britain, Germany, France, Italy, Canada, Russia, along with China, India, Brazil, and it said climate change is undoubtedly real, it's caused mainly by us, and it's really serious. That was followed by Nick Stern's review of what's it going to cost to do something about it. And his estimate is that in order to try and stabilise the thickening blanket at somewhere around the general order of double pre-industrial levels, which arguably is going to mean that although there are going to be major changes, they're not really going to be really catastrophic, that could cost as much as 5% of GDP, although equally it could be a benefit of 2%, and a characteristic number would be perhaps 1% of GDP, which these days, after all, sounds like a lot compared to how it's increasing. And conversely, if we don't do anything, then the costs are going to be much greater. So that leaves you with this cover of the British Ecological Society's journal of we really need to be doing something. And what I'm going to do now is shift gear and tell you what the UK decided it would do. This is the cover page of the first of the initial report on the recommendation to the government of what we should be doing. And it comes out of a legislative process which began in somewhere early in 2008 or late 2007 with the introduction of a climate change bill. And interestingly, the government did a rather bold thing. At the same time as it introduced a bill that was going obviously to take a long time going through both houses of Parliament, the bill has 3 bits. It says we're going to set targets, and then we're going to set up an independent committee that will recommend these targets to the government and monitor the progress year by year. And it set up that committee at the same time as it introduced the legislation. So it took about a year before the bill was passed. It was passed in December 2008. And 3 days later, the committee, which hadn't formally existed until 3 days earlier, and who had got their letters of appointment, even though they'd been working for a year, sometime in that 3-day interval, produced its first annual report. It produced its second annual report in December 2009, last year, and I'll come to that in a moment. In going about its business, the committee asked, how are we going to, what is the intellectual basis, and for that matter, almost the philosophical basis on which we're going to set the 2050 target? And it went about it by saying, first of all, if as a planet we are going to hold greenhouse gas emissions to a certain level, what's the appropriate level to be aiming for? And then on that basis for the global effort, ask what's the appropriate fair share for the UK? And then ask how we can get there. Is it feasible? So take the first one first. How do you go about deciding what the global emissions reduction ought to be? And that's going to depend on science becoming a little bit better able to make estimates of how much stuff you put up there, how it translates into temperature. And the assessment there, which comes from the Intergovernmental Panel on Climate Change, which involves thousands of scientists from essentially all the world's countries, embracing dissent, everything open to challenge, and very rarely, but not it's not perfect. It's made at least one cock-up recently when it's let slip through something suggesting that there was a 35% probability. There was a quite high probability that all the Himalayan glaciers had been gone by 2035, which is really at the outer end of the projection. But apart from that, they've consistently erred in the direction of conservatism. Things have actually got worse faster than the worst predictions for most indices for the Climate Change Committee. The decision rule that the Climate Change Committee in the UK adopted was based on the IPCC thing that said if you can hold emissions by 2050 below 450, 500 parts per million, then you've got a 50-50 chance that you're not going to go beyond 2 degrees of warming, which, as I say, on a global average is a hell of a lot, even though it may be in the noise day to day. And that also simultaneously means your chance of getting into the area where you really face serious disruption, a 4 degrees centigrade rise is less than 1%. Then you can turn round and you can say what that really means is here's the amount of emissions we're going to want per capita with the 9 billion people we're going to have in 2050. That translates into saying for the overall global reduction, you're going to want somewhere between 2 and 2.5 tonnes of CO2 equivalent, not just CO2, but CO2 equivalent, other greenhouse gases per capita, as a global average. That means India and China would be moving up to that from where they are now per capita, but more slowly than the trajectory they're headed on if they were to play their fair share, whereas countries like Britain and a fortiori the US would be moving down to that. That's the basis. You work out what you need for the average person, and then you assume fair shares. Everybody by 2050 is going to be fair shares. Dream on, believe that. And what's the UK's fair share on that basis? Well, we've got to come down, and in fact, initially it was thought that that would represent coming down 60%. But as we are learning more in the last few years, that turns out that the UK has got to come down 80% per capita by 2050. And that was recommended to the government before the legislation existed and accepted. The conclusion is you can do this, it's feasible, including aviation and shipping. But to do it, you're going to have to start acting now, and you're going to have to aim unilaterally, and this is a sort of interim target, of a 34% cut by 2020 relative to 1990. But the intended target is a 42% cut by 2020. But if that will only switch in after at least an EU and preferably a global deal is achieved. This is what was recommended a little over a year and a bit ago, because otherwise trying to get to 42 would just be too out of sync with what everybody else is doing and would be untenably uncompetitive for Britain industry. And the estimated cost of that is 1% of GDP by 2020. And that's a non-trivial challenge. Here's a rough idea of how one has gone into that in great detail, the various aspects. The most important thing is to decarbonise electricity generation, transport, residential and commercial heat, other aspects, other gases, the other CO2, other greenhouse gases, coming down 80%. There have been subsequent reports. I myself can't read this rather blurry thing, but if my memory is correct, that's the initial report. There's an aviation report looking to 2050 and asking what we might be able to do there. And there are technical problems with trying to do this for a single country that can be overcome, and the technical problems are even harder for shipping. And then here's the first annual report, the annual report of accounts, and the first annual report as distinct from the zeroth report from December 2009, which is called, which you obviously can't read, Need for a Step Change. Because already 1 year into the government accepting the targets, it's not at all clear. I mean, we've fallen behind the run rate already. It's an analogy that I like and which is intelligible if I say it in Australia and somewhat less in America. We're already behind the run rate. One of the questions that many of us have asked is, So we've got these binding targets. What if we don't meet them? And the anodyne answer is, well, they're legally binding targets. And that's not an answer. That's just a restatement of the problem. I personally think that one major member of cabinet should have to be executed, would provide a sort of stimulus that might focus minds, or at least maybe the Prime Minister could resign or something. But at the moment, we are behind the run rate, and the first annual report says that quite boldly. This is showing where we started. The trend was already coming down a bit, and it's got the business as usual top slide, the thing down 34% aimed reduction, and the 42% aimed reduction. Now that's all very well for what Britain is doing, and it has been, I think it's fair to say, a real leader in talking the talk and trying to influence others, and it's been reasonably good in walking the walk, because although it's behind the run rate, it's ahead of most other people's run rates. If it were a cricket game, I mean, if you were against some abstract run rate, it'd be a bloody awful game of cricket, because no one would be scoring very well, but the Brits would be winning, which is be most unusual. They'd certainly unusually be beating Australia.